The Death Star, the Halo Array, Dyson Spheres. Nothing really captures the spirit of science fiction like megastructures. Impossibly huge, made with technology we can scarcely comprehend. It's a way of saying, hey, our species has really grown up. We ain't stacking stones anymore. We're building serious stuff now. Alternatively, when we find a megastructure not made by us, it gives a kind of scientific vertigo. What were these absolute mad lads capable of, and what wiped them out if they were so much more advanced than us? Plus, it just tickles the monkey brain to see something so gosh darn big. And in all the annals of sci-fi, there is a megastructure that hits on all of these story beats that also happens to be the biggest sci-fi megastructure ever seen in fiction, an entity known only as the City. But first, some context. And before we begin, keep in mind I am making none of this up. Hailing from the semi-obscure manga Blom, yes, it's actually pronounced that way, it's supposed to be the sound of a gun going off, the City is a megastructure of mind-boggling size and unspecified but vast time in the future, where builder bots who pull matter out of alternate universes built infrastructure at human command. But a war caused by a cyborg cult caused the extinction of humans with the correct genes to command these builder bots. Lacking direction, these builder bots build and build and build for thousands of years. They build stuff that, according to their programming, resembles human infrastructure, but has no direction, creating nonsensical structures with no rhyme or reason, like a generative AI running 24/7 with no human input. Some parts of it are functional, but most of this world is hostile nonsense. Welcome to the City. Now, of greatest importance to this video is, the City is big. Like, really big. The name might be a bit misleading. If it's called the City, you may think it covers continents or most of the world. But no, it covers most of the solar system. And I don't mean it just covers the things in the solar system. I mean the actual spherical volume itself. Size estimates are vague, but the author said that the City reaches out to the edges of the solar system with a multi-layered spherical shell structure being about out to the orbit of Jupiter. As far as I can tell, that's the biggest thing in sci-fi. Sure, there are things with bigger absolute dimensions, like precursor star roads from Halo, which, as the name suggests, run between star systems, but nothing with the volume the City has. Things reach farther, but they don't occupy the same space. Its only real competition is the Webway from Warhammer 40,000, which stretches across the galaxy, but I don't count that because it's mega vague and its wishy-washy magical elf crap or distance and time are all wonky and don't really count for much, so I am disqualifying that. But how do we know how big the City actually is? What do we mean by biggest thing in sci-fi anyway? The City might be a big ball in space, but without a way to contextualize those numbers, it just becomes meaningless technobabble. But luckily for you, we have a solution. Now, the history of this deep rabbit hole that I forced myself to go down is this whole topic comes from a conversation I was having on Discord with a friend of mine. Let's call him Robert, because that was his name. We were discussing the City versus a better known example of a big giant thing in sci-fi, the Imperium of Man. A horrible space dystopia with a million worlds under its belt, and this is where the important values come in. Comparing it to human territory grounds the discussion. How do you measure how much space the Imperium of Man has? Well, by how much planetary surface it has. So to compare, we check how much usable area, not volume, area, the City has in it. For reference, the Earth has an area of about 5.1 million square kilometers. Keep that figure in your head because these numbers are going to get very insane very quickly. Now, the series is pretty vague about a lot of the details of the City. It is a visual medium. It is not meant to be measured scientifically like what we're doing. So we're going to have to make a lot of assumptions. So please buckle your seatbelts. We're going on a ride. we assume that for usable area, only the part that reaches Jupiter's orbit counts in any meaningful way, and that it is laid out in perfectly spherical layers. Yes, there are parts that supposedly reach all the way out to the edges of the solar system, but we're talking about human usable area here, and tendrils out into space probably don't have much of an atmosphere. Meanwhile, while we see structures that seem to have stacked up floors that increase the usable area and places that are too sheer or too hostile in general for humans to make use of, which decreases the area, we're going to average this all out into functionally being flat at the macro scale. For assumption 2, we need to introduce Blom's protagonist, Killy. Yes, that is his name. Shut up. Now, Killy is a robot man, and he's on a mission. For what? Isn't important here, but it's said walking between layers takes him about a month. Given the huge stretches of time between when scenes happen, and that Killy is an untiring robot man who probably doesn't sleep, let's put his walking pace at a brisk 3 kilometers an hour, or just under 2 miles an hour, and he spends 90% of his time walking at this pace, and inclines don't change his speed much since his muscles don't get tired. Now clearly he doesn't walk straight up, so we need to figure out how his walking speed translates to vertical distance. Which brings us to... the city is built for trains. Now stay with me on this. Like I said earlier, the builder's activity strongly resembles AI gone out of control, and when the disgusting, putrid AI bros have tried to use AI to try and make more efficient infrastructure, it keeps reinventing trains. So if we give these senile AI bots free rein to design infrastructure, they're going to think everyone is train-shaped. A cursory glance says that the steepest incline a modern train can handle is 35%. The world has much more advanced technology than our modern day, as evidenced by, well, you know, everything. So these future trains can maybe handle a steeper slope than our real-life trains, but again, this is about making efficient infrastructure, and I'm also not here to work out theoretical train slopes, so we're going with 35%. Fight me on it. With all of this info put together, we can start to work out how much internal surface area the city has. Warning, this section has math, like for real, a lot of math. Now, if Killy takes a month to walk between levels, that's 756 hours on average, and he spends 680.4 hours of that walking at 3 kilometers per hour, meaning he walks an average of 2,041.2 kilometers every month. Take the arctan of 35% incline to have a 19-degree upward angle, take the sine of that, subscribe to my YouTube channel, multiply by the hypotenuse, more math, and you get a vertical distance between layers of 674.3 kilometers between each layer. Now, we said earlier that the spherical portion of the city extends out to the orbit of Jupiter, which is 778 million kilometers. If we divide Jupiter's orbit by the distance between layers, we get how many layers there are, which is 1,153,789 layers, each of which is a sphere smaller than the last. Now, calculating the surface area of a sphere is easy. It's just this. The problem is, calculating over 1 million of them one by one would take most of the rest of my life. So I decided to break out a tool I hadn't used in a while: calculus. And then I remembered I don't need calculus because we can just use summation, otherwise known as sigma. Yes, I'm a sigma male. God damn. Anyway, this didn't work because the sigma calculator I used had a maximum number of steps set at 1,000, which was less than 1,153,789 steps that I needed. A lot less, in fact. So I opened up C# to code my own summation calculator. See, it's right there, looking good. Don't roast my coding, please. I am trying. And then it took a while, because doing over 1 million code loops takes a long time. And then another friend of mine, one with a math degree, caught wind that I was trying to calculate a ludicrously large number and had an equation that solved my problem. The nth square pyramidal number, which was a gift from the divine. This equation has saved my life. This equation baptized my child. It has filed my taxes and tucked me into bed. This is the best equation of all time, and I will not be hearing any backtalk. No, this is not trauma bonding because this equation solved the problem I was working on for over an hour. Shut up, my feelings are legitimate. Anyway, with the help of the nth square pyramidal number, he and I calculated the final number we were looking for. Using this equation and the spherical surface area calculation, we calculated the total usable area of the city being 3 septillion square kilometers. That's a 3 followed by 24 zeros, by the way. So, that's about 588 quadrillion times the size of the Earth. Like, even then, this number is so redonkulously massive that I can't find any clever comparisons. That's so many Earths that if every star in the Milky Way had an Earth-mass habitable planet, you'd still need almost 1.5 million galaxies. The habitable space of the city is so vast, it's not just unfathomably big, it's functionally infinite. Consider the following. If we measure the time it took to explore the world as being between the creation of the first known map and the time we landed on every major landmass, it took us about 3,700 years to map out the Earth alone, including the last century or two where we were actively trying to explore it. It would take hundreds of thousands of times the age of the universe to plot the city with any level of detail, and depending on how fast the builderbots build, they may make more city faster than we can explore it. And to say nothing of the isolation, there are still uncontacted tribes today with only one Earth to work with. With an area 588 quadrillion times bigger, entire globe-spanning civilizations could pop up, expand, thrive, slowly decline and collapse without ever even knowing others were out there. And yet, Kili runs into people several times. There are distinct cultures and settlements, and given how the city is just a tad hostile to human life, there sure aren't enough people around for him to run into them randomly by sheer chance. It must be that areas the human-shaped Kili can use, and thus the areas real humans can use, must occupy a small portion of the actual area of the city. Thin spiderweb of habitability stretched over a vast machine wasteland, like the first civilizations appearing around rivers in a big and dangerous world, mirrored here on a much larger scale. They're even both filled with crazed monsters that will happily kill you for being in the wrong place. So, the city is big. Really damn big. So big that humans with modern technology and beyond inhabit it like early humans on Earth did, with isolated tribes that will never mate each other and civilizations clinging to a network of human-friendly areas. It just goes to show, in the vast scale of space, we are still little more than cavemen. Or, it's just a really big place to let the author do some badass set-piece drawings. Either way works, right?